So next we'll do demonstration of verification of Norton's theorem. So this is a circuit for Thevenin's theorem. So same Thevenin's theorem circuit we can use it for Norton's theorem also. So in the Thevenin's theorem we applied Thevenin's theorem and defined the current. So here we are going to convert this circuit into Norton's equivalent circuit. So statement. So Norton's theorem states that any linear bilateral network consisting of any number of sources, okay, that can be converted into simple circuit with one current source and parallel with one resistance. So in the Thevenin's theorem we actually converted into single voltage source and single resistance in series with. So in the Norton's theorem, volt instead of voltage sources it is current source in parallel with resistance. The Norton's theorem and Thevenin's theorem are complement each other. In the Thevenin's theorem, we have voltage source in series with resistance. This voltage source, if you convert it into current source, okay, the value of the current is VTH by RTH, and you will get the current value. And RTH you have to connect parallel. So if you know voltage source and resistance value, you can convert this voltage source into current source. And similarly, if you know the Norton's equivalent circuit, you can convert it into Thevenin's equivalent circuit by converting current source into voltage source. Both are complement to each other. So now I will not repeat the procedure of the question for this problem is find current through 20 ohm resistor. Find current through 20 ohm resistor using Norton's theorem. So now I have to first step is what? First step is in the Thevenin's theorem as well as in the Norton's theorem, we have to remove the load. So here we have to find the current through 20 ohm. So this you have to consider as load. So you have to remove this. So in the next circuit, you copy. First you have to rig up this circuit. I will those who are seeing only this video, I will repeat how to do this. So you have to go to place component. Okay, go to place component. Then you have to search for resistor. So resistor is present in basics group. So four diodes, four resistors you have to pick. Okay, in the basic resistor is there. So you can select 20 ohm, 10 ohm, 5 ohm resistors. And to rotate the resistor, once you place here in the editor window, you have to select that component and you have to press Ctrl R to rotate vertically 90-degree right side, down, left side, like that you can rotate. Okay. Four resistors you have to pick and place, and to place power supply you should go to sources, then power sources, ground you will pick here, DC power you can connect this, and similarly to get the current source, signal current sources. So here you can select DC current. So this is explained properly in Thevenin's theorem circuit. So now I don't want to waste time in rig up the circuit. So in the main circuit, okay, actual circuit, the overall response we are getting is 2 amps. Okay, same circuit I am using because same circuit we are solving using superposition theorem, Norton's theorem, Thevenin's theorem. In all the methods, the answer should be same. Okay, you can which one is easy for you? You can they don't specify any particular method to find the current. You can use any method which one is easy for you. So this is with the circuit. Okay, the actual circuit we are getting 20 ohms resistor. The current is actually 2 amps is coming. Okay. So now with the simple Norton's theorem, Norton's equivalent circuit also, you should get in the load 2 amps only. Then only we can tell that Norton's theorem is verified. So for that, you should find out what is short circuit current. In the Thevenin's theorem, you have to find out open circuit voltage across the load terminals. With the load is removed, across the load, you have to find out open circuit voltage. So in the Norton's theorem, you have to short circuit those two terminals and you have to find out current. So in order to find the current, you have to use a multimeter, or you can use ammeter directly. So if you use multimeter, you have to set that knob to uh, amps. So here, this is a circuit I did for Thevenin's theorem. In Thevenin's theorem, we removed that load, 20 ohm load we removed, and we connected on multimeter, and you can check it out. This is actually set to volts here. So in the this is you can, if you want to use this multimeter as a ammeter, the here you click on A, so that it will be highlighted. If you want to use it as voltmeter, you have to click on V. If you want to use it as a ohm meter, you have to click on ohms. And you can also find out here decibel is also there. You can do this also. So now I want to use it as ammeter. You have to connect. This is a short circuit. Okay, you can short circuit this, and you can use multimeter in ammeter, and it should be in series with this. So now let me see what is the short circuit current here. Okay, I am running this. Here you are getting you are getting 1 minute. You have to click here, run button. You have to click green color button. Now it is showing short circuit current as 5 amps. So this is the method. You can use ammeter. You have to connect in series. Always current. You have to if you want to measure current, you have to connect ammeter in series. Okay, that's why. Otherwise, if you want to use probe, I will show that method also. If you want to use probe, then you can remove this. Okay, now you see here, I want to short circuit these two now. I want to short circuit these two. So here you cannot draw a line short circuit, because always connection should start from edge of the component. So what you have to do is you have to remove the one more line, short circuit these two. Here actually 20 ohm resistor was there now. This 20 ohm I shorted because I have to find out short circuit current here. And see here, now connection is possible because here also edge is there. Now we inserted. Okay. Now I have to find out current here now. So multimeter, if you cannot connect here, if you connect multimeter here, it becomes parallel. So that's why you have to remove this connection and you have to connect series previous diagram. Now if you want to see with short circuit current, you can see go to probes here, current probe. And here also you can get the same current value with the probe value. And the previous one I showed with the help of multimeter set as ammeter. So here also you can see 5 amps is coming. So this is actually ISC or IN. IN means Norton equivalent current, or I short circuit. Short circuit current is 5 amps, or IN, Norton equivalent current is this one. So now I have to find out equivalent resistance. To find a resistance, method is same for Thevenin's as well as Norton's. Same method. You have to make all the sources 0. So first we'll make 20 volts is equal to 0 by short circuiting this. Remove this line and short circuit. And its entire right side and this full path, you can delete it. Then only current becomes 0. If you short circuit the current source, okay, all the current will pass through this short circuit path only because of less resistance. So that's why current source you have to open circuit in order to make 0 current. So I removed that. Okay, now I have to look from this load terminal. Load side, load 20 ohms was here, no? Load 20 ohms was here. Looking from this side, so I can rotate this right side. I can keep I connected like this. Both are same only, no problem. So this is a multimeter. I'm looking from 20 ohm resistor. Load is removed, no? With the load is removed, and you have to look into this terminal. What is the equivalent? You have to see. And here, this 20 volts is short circuited. Voltage source is short circuited. This voltage source, this is short circuited. This current is removed, and we are looking from 20 ohm resistor. Okay. Now this multimeter, it is for multi-purpose. You can use it for different. Say you can use it for ammeter, voltmeter, and ohm meter. Now we are measuring resistance, so keep it in ohm. This ohm is highlighted. Now once you run, you will get 13.33. So that is 5 parallel 10. You are going to get 3.33 in series with 10 ohm. So between these two terminals, see between this node, this is you can see the node here. Between this node and this, okay, we have 10 ohm and another 5 ohm. These two are in parallel. So 10 parallel 5, okay. 10 parallel 5 is 10 into 5. R1 parallel R2 is R1 into R2 divided by R1 plus R2. So 10 into 5 divided by 10 plus 5. It will give you 3.3. Okay, 3.3. And that 3.3 is in series with 10 ohm. Okay, that is in series with 10 ohm. So plus 10. So that is the equivalent resistance. So R Thevenin is equal to, so here we can call it as not R Thevenin, we can call it as Rn, Norton's equivalent. After that, what you have to do is you have to draw equivalent, okay, equivalent Norton's equivalent circuit. So for this, you have to remove this R, you have to connect parallel. So this you have to rotate right side, control R you have to press. I removed the 20 VTH, previous circuit was there, no? That I removed. RTH I have to connect parallel, and I have to use here current source, short circuit current source. So that you have to pick from place component, then go to sources group. In the sources group, go to signal current source. In the signal current source, select the DC current. Click OK. Default value of current source is different actually. It is showing 1 amp. So you have to change this one to how much you got here. How much you got here? Here we got 5 amps, no? Let me check that. Short circuit we got 5 amps. This is the ISC, short circuit current. And resistance also you have to use this TH value, that is a 13.33. So now I will change this one to 5 amps. You have to double click on that, and you can change the value to 5 amps. Default value is 1 amp. Now it is changed to 5 amps. Okay, now it's not changed. So simulation is running, you cannot change it. You have to stop. Okay, now complete the circuit. We are writing Norton's equivalent circuit. We are getting two dots. Okay, this is IN. or ISC short circuit current, and Norton's resistance. That this you can change this one to RN. Rename is without renaming also you can execute, no problem. This also you can rename it to, instead of I3, you can rename it as IN RN. This is the label. So you have to change, instead of RTH. Value is different, label is different, okay? RN. So subscript you cannot write, so RN continuous will come. And similarly, IN. N stands for actually Norton's equivalent circuit. So now I'm going to execute this. IN or ISC short circuit current, you can use anything. After that, which load we removed, same load you have to connect. Here, question is find the current through 20 ohm resistor using Norton's theorem. So this is the load we removed and we calculated ISC by short circuiting this, and we calculated resistance looking from the, when you open this load, looking to this load, you have to make all the voltage source short circuit, current source removing, and the equivalent resistance you have to check. After that, same load you have to connect in the Norton's equivalent circuit. We removed 20 ohms. So same 20 ohm you have to connect here. So now when this circuit is verified, Thevenin's theorem is, Norton's theorem is verified, means you should get the same current which was actually running that time, the original circuit. So I can move this full circuit copy and you can place nearby. Okay, now here you should get 2 amps only, because in the original circuit with all complicated network only, we are getting 2 amps here. So same 2 amps should come here also. So now to check the, again you can connect one voltmeter. You can connect in series. You have to remove this path and you have to place multimeter. Connect one left side to here, right side to here. So that multimeter should come in series between these two. Now I am using the probe, so that's why I am shorting here and just connect the probe, current probe. So this reading should give you me same 2 amps. Then the theorem is verified. Now I am running this. To run this, this is the green color button. So we'll see what is the answer. So in the actual circuit, how much is coming? In the actual circuit, 2 amps is coming with the voltage source, everything is. This is a complex network. Now the complexity is reduced with the help of short circuit. Short circuit current is 5 amps. Here I'm using probe. You can use probe or you can use multimeter in ammeter, set it, or you can connect ammeter in between this. Ammeter is present in place indicator, ammeter you have to select, plus here negative this side. Ammeter also have to connect in series. After that, RTH, now you can see what is the current in the simplified network. If you observe here current is 2 amps. So 2 amps is coming here. IDC is coming 2 amps. I'm using current probe, that's why. So ISC is 5 amps. Norton's resistance is 13.3. We connect this. So we know the current division formula. Current in 20 ohm is main current ISC. Resistance opposite to RL is 13.33 divided by total resistance RN plus RL. I repeat, current in RL is main current into Rn divided by Rn plus Rl. Theoretically also it is correct only. You can check it out. It is 2 amps only. So I'll show, if you want, I'll show calculation. It is not there. Okay, you can calculate 5 into 13.33 divided by 20 plus 13.33. It will give you 2 only. So this is the verification of Norton's theorem.